on. Okay, we'll go over this handout and talk about sample spaces. And then here's this pamphlet that I handed you. The pamphlet that I handed you is about, it's your homework assignment, but it's also your study guide. Most of it is explaining some information that you need to know. But I want you to get this out first. We're going to take a few notes on it. Okay? We're going to start with sample space. Whoops, I didn't mean to put a dash right there. Sample space. As it says on here, it says the set of all possible sample points. I want you to, above sample points, I want you to kind of cross that out and put the words outcomes, okay? The set of all possible outcomes. You will notice that up above that it says the most basic outcome, there's the word outcome, everybody underline that word outcome, of an experiment is called a sample point. So this paper right here is calling it a sample point, an outcome, but that's what it is. Let me give you an example, okay? We have a 6-sided die. Well, let's start even more simple. Let's get a coin. We don't need, okay, got a coin right here. If we take a coin and I flip it, I probably don't even need the coin, but, all right, thank you. Wow. Ooh. Okay, here we go. What is this, a $1 coin? Okay, if I take a coin, this is a $1 Jefferson coin. My eyes are getting bad. So Thomas Jefferson on one side and the Statue of Liberty on the other side. Okay, if I take this one coin and I flip it, what are my possible outcomes? Heads or tails, right? Okay, so my possible outcomes are heads or tails. And just to show you how you write that, we write it in set notation. See these things right here? We put them around all the sample spaces or the sets or the subsets of when we write something as a set. Okay, my set of things that I can possibly come out with are heads or tails, right? Okay, so that's how we'd write the sample space for, that's how we'd write a sample space for flipping a coin. What about the sample space for rolling this die right here? 1, 2, 3, 4, 5, 6. So my sample space for rolling the coin is 1, 2, 3, 4, 5, and 6. That is my sample space. You got it? So does everybody understand what a sample space is? Okay, I'm going to give you a couple of problems. I meant to get here earlier and write them down. I didn't get here in time to write them all down. So I'm going to write them down right now for you. I want you guys to come up with the following sample spaces. I want you to choose the sample space for choosing a random number. Okay, let me. Okay, number 1 is choosing a random number between 1 and 9. Let's do it on this piece of paper on the back side of it. Okay, that's the first one. Go ahead. I want you to work in pairs or in triples if you got 3 people. Okay. So Kayla and Audrey and Carly, you guys will kind of work in pairs. So check with Kayla behind you. Also, you guys work with Kobe over here. Kai and. Okay. Here we go. Number 2. The possible results when A plays B in 2 sets of tennis. Number 3. The results when tossing a dime a quarter and a nickel. Yep. Simultaneously. I don't know if I spelled that right, but I was writing it fast. Okay. I want you guys to discuss this with your shoulder partner and see if you got the same sample space. You should just be able to write the sample space down fairly quickly. Maybe for your notes, you might want to write these down. What was that? Yeah. You're going to either get heads or tails on each one of them, right? Yep.
Would you have 3 different
You want me to go over these 3 with you just to make sure you guys understand? Okay. Let's number 1, what's No, that's not right. Who said that? What'd you say? 2, 3, 4, 5, 6, 7, 8. There's the correct answer. Good job. What? Well, we just want to know the sample space. What's the possible outcomes? Huh? It was 5. All right. Hey, you guys. Remember, this is a sample space. We want to know the possible outcomes. That's what a sample space is. Okay? What's the possibilities here? Well, okay, let's say they play a game. Okay? Let's say they play a game. And, well, see, the possible results when A plays B in tennis, right? Okay, so if they're going to play 2 sets. Wait, I didn't write that down correctly. The possible results when A plays B in 2 sets of tennis. I didn't write that down correctly. I thought that 2 sets of tennis. Okay? The possible results when A plays B in 2 sets of tennis. Well, we could have AA. You know, what does that mean? AA. Wins A both of them. When A wins both of them. We could have AB. What does that mean? A won, then B won the second one, right? BA means that B won the first one and A won the second one. What's the last one? BB. B won the first one and B won the second one. That's all the possible results, right? There's no such thing as a tie in sports. In my book. All right. All right. Okay. All right. Those are the possible things. Okay, now, you guys, when you do this one right here, when you do this one, the results when tossing a dime, a quarter, and a nickel simultaneously, let's do it in that order. Dime, quarter, nickel. Okay? You could get heads, heads, heads. You could get heads, heads, tails, right? What's the next one? How about heads, tails, heads? And how about tails, heads, heads? Let's do it so there's one tail on each one. Do you see I'm showing? I'm kind of doing it in a systematic way so we don't miss one. Okay, whoops, I put commas after all of those.
I know.
Tails, heads, heads. Then let's do it with two heads, tails, tails. And what was that? Tails, tails, heads. Tails, heads, tails. Is that all of them with one head winning? Okay. And then is tails, tails, tails the last one? How many are there? Now, you guys, when you are doing probability, you guys all know basic probability. Like, for instance, if I said, with this die right here, what's the probability of rolling a 6? 1 out of 6. And so what you did is you took all the desired outcomes, right? You wanted a 6, and you put it over the possible outcomes, which is a sample space. Do you understand what I'm saying? The sample space is the bottom number of your probability fraction. Everybody write that down. Your sample space is the bottom number of your probability fraction. Sample space is your bottom number of your probability fraction. Okay, I'm going to give you a couple more of these problems to do. Ready? The bottom number of your probability fraction. So, like, let's go back to this one right here. Okay? What's the probability I'm going to roll? I'm gonna, when I flip these coins on number 3, what's the probability I'll get 2 tails? Just 2 tails, exactly 2 tails. Well, my desired outcomes is there's 2 tails in that one, 2 tails in that one, and 2 tails in that one, right? 3 out of 8. My sample space is the bottom number, 8 possible outcomes. My top number is the number of desired outcomes, right? So the possibility of getting 2 tails when I flip the coins is 3 out of 8. Does that make sense? Okay? And so sample space becomes really important because you guys have got to know how to figure out how many possible outcomes there are. Now, they get more difficult. We've done some easy ones. And so far in you guys' math careers, you guys have always done simple probability where the number of the sample space on the bottom is easy to count, right? And so we're going to get into some more complicated ways of counting sample space. And we'll be doing that as this domain goes along. But we need to know how to understand sample space. Okay, let me give you a couple more sample spaces. Let's do this one right here. The sexes of a 2-child family. Maybe I'll put gender. Of a 2-child family. The genders of a 2-child family. Okay? I don't know. The genders of a 2-child family. What are the possibilities? This is like, okay? You got male, 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 female, female, male, female, female. Got it? Okay? The genders of a 2-child family. Okay. Okay. Yeah, forgot about the cousins. Okay, you guys. The order, let's do this one. The order in which 3 men can be lined up. How about that one? The order in which 3 men can be lined up. You can call them whatever you want. A, B, C, 1, 2, 3. Hot, not hot, and semi-hot. Okay. I'm going to use A, B, and C. So, or you can use 1, 2, and 3.
Use 1, 2, and 3.
All right, we'll use 1, 2, and 3. So, 1, 2, 3. What's another one? 1, 3, 2.
2, 3, 1.
2, 1, 3.
2, 3, 1.
And 2, 3, 1.
3, 2, 1.
3, 2, 1. And 3, 1, 2. That should be all of them, right?
Yeah.
Oh, wait. Yeah. I did it where 1 was the first one in the first 2. 2 was the first one in the next 2. And 3 was the first one in the next 2. It just helps if you do something, you have an organization of how you do it. Yeah.
Isn't there like a kind of like times something or other to find out how many there are?
Well, these are just representing a person.
For numbers, like a bank account has like certain kind of numbers, and you want to count it or whatever, and then like you have to find out how many.
Oh yeah, you're thinking of a permutation. Like you want to know how many ways that you can organize. You want to know how many different numbers you can make with the number 1, 2, 3, 1, 2, and 3, right? That's kind of like this. Yeah, it's called 3 factorial, or a permutation of 3 things arranged, and you're going to get 3 factorial, which means 3 times 2 times 1, which is 6.
Yes, because the first one has the first like.
Yeah.
So 1 has 3 possibilities there, 2 has 3 possibilities.
That's right. Yeah. So like once you got 3 ways to choose the first slot. Once you choose the first slot, you got 2 ways left to choose the next slot, and then after you choose that one, you only have 1 number left to put in the last one. Does that make sense? How do you know if you what? Well, okay, Haley asked a good question right here. She asked, how do you know when you're all done listing it? Well, in this case right here, I organized it. So what I did is the first 2, I put a 1 in the first spot, right? And so the only other way you can go 1, and then you got 2 and 3, or 3 and 2 after that, right? So that was if 1's first. Now I'm going to do it with 2 first for the next 2. And you can have. Well, there's an easier way to count high sample spaces. It was like Colby was just. Have you guys heard of permutations and combinations? Okay, permutations and combinations is a way of counting sample spaces quickly, but that's way more advanced than what we're doing today. So we're going to move on. I don't know. I haven't looked far enough. I've looked a little ways up on the domain. I don't know if we're going to do permutations or combinations for sure. Okay, let's do one more, you guys. No, I think you guys get this. Well, let's do another one. What happens when we have, there's another way to organize it. Let's say I want to do this one right here. Rolling a die and tossing a coin simultaneously. Rolling a die. You guys know what a die is, right? Yeah, a die is singular for dice, right? Okay, you guys all know that? Okay, rolling a die and tossing a coin. Simultaneously, okay? So, well, we're assuming it's a 6-sided die, okay? Yeah, that's a good question. And we're just, you guys, the other thing about this is when we're talking about a die, Andrea brings up a good point. If I just say a die, I always mean a 6-sided die, okay? If I specify what kind of die, because there's 12-sided die, 20-sided die, right? And there's other types of dice. But when I take this die right here, if I roll it, if there's a chance, an equally likely chance that all of them can come up, we say it's a fair die. Okay, but some of them are loaded, right? They have more weight on one side than the other, and so more numbers are going to come up. Some numbers are going to come up more than others. Okay, so that's if someone's cheating. They have a loaded die, right? They know what's all. You know, it might be that getting a 6 is not as likely as getting a 1. Okay. All right, rolling a die, tossing coins simultaneously. I want to show you guys a different way to organize this. We are going to use a grid or a table. Okay. We're going to use a grid or a table. So I'm going to draw this right here. You can do the other way if you want. It just might be faster to do it this way. 1, 2, 3, 4, 5, 6, and heads, tails, right? And then we can do this. You have the possibility of getting a heads and a 1, a heads and a 2, a heads and a 3, a heads and a 4, a heads and a 5, and a heads and a 6. Do you understand what I'm doing here? And down here, what would it be? Tails 1, tails 2, tails 3, tails 4, tails 5, and tails 6. Do you see how a grid can help you when you got two things like that? That it can help you come up with a sample space a lot quicker. Okay. All right, so well, I'm just leaving it for him to organize it sometimes. So. All right. Okay. Number 2, or B. Let's do another one. Okay, let's do rolling a pair of dice. I'm going to let you guys do this one. Rolling a pair of dice. Rolling a pair of dice. Rolling a pair of dice. I'd make a grid. We want to know all possible outcomes. We're doing this as sum. So 2 plus 1 would make 2. 2 plus 2 is 4. 2. Yeah, 3. 2 plus 1 is 3. 2 plus 2 is 4. You know, I like it when I make mistakes like that. You guys always correct me on them. I got a couple classes. I could probably go up here all day making mistakes and no one ever says anything. So. 5, 6, 7, 8, right? 4, 5, 6, 7, 8, and 9. 5, 6, 7, 8, 9, 10. 6, 7, 8, 9, 10, 11. 7, 8, 9, 10, 11, and 12. All right. Now, I'm going to ask you guys a couple of questions just to test you out.
If you were to put that in a bracket, would you just put 2 to 12?
Well, it depends on if... Okay, did you guys hear Audrey? Good question. If I was to put this in the brackets and put it in set notation, would I put the sum numbers, or would I put 1 and 1, and then 1 and 2, and then 1 and 3? It depends on what you're asked for. Okay, I meant to ask you guys for a sum when I wrote this down. But so you can do it either way. It just depends on what is asked for. Okay. Yes. Then you could put 1 comma 1, 1 comma 2, 1 comma 3.
Would you put 3 twice and 4 3 times?
Yes, you would. Because see this 5 right here? That's rolling a 3 with the first die and a 2 with the second die, right? Whereas that's different than the other way around. If you went right here, a 2 with the first die and a 3 with the second die, right? Yeah. Because they're two separate, the dice are separate. They're not the same one, okay? All right, hey you guys, what is the probability, and now I'm going to ask you guys a probability question. What is the probability of rolling a sum of 4? When you have the answer, share it with your shoulder partner and then raise your hands. What is the probability of rolling a sum of 4? When you know it, share it with your shoulder partner and then raise your hands. A sum of 4. Andrea, check with those two, see if you guys got the same thing. We'll make sure they got it right. That's what I'm saying. Just kidding, you guys. Andrea's got to learn to talk to you guys. Come on, turn around and say something to him. Anything. Doesn't have to be the answer. Okay. All right, who's got it? Okay. Haley, what do you think it is? 3 out of 36. What does that reduce to? How many of you had 1 out of 12 or 3 out of 36? Okay, that's right. 3 out of 36 is right, but usually we reduce properties, so the answer would be 1 out of 12. Okay? Next question. What is the probability of rolling? Let me ask you. What sum do you have the highest probability of rolling? When you know, raise your hand. Don't say it out loud. What sum do you have the highest probability of rolling? What sum do you have the highest probability of rolling? Check with your shoulder partner, see if you got the same thing. Okay. Alex, what do you think? 7. Why? Yeah, how many 7s are there, you guys? 6. So what's the probability of rolling a 7? 1 out of 6, because 6 out of 36 reduces to 1 out of 6, right? Okay, all right, I'm going to get you on this one. What is the probability of rolling a sum greater than 7? What is the probability of rolling a sum greater than 7? What is the probability of rolling a sum greater than 7? When you know, raise your hand. Share it with your shoulder partner too. It's not a trick question. It's pretty straightforward. Okay, Shawnee, what do you think? Yeah, I believe that's right, because it's, what was the original number? 15 out of 36, right? 15 out of 36 reduces to 3. We're going to 15 how many times? 5. We're going to 36 12 times. 5/12. Got it? And if you look, the numbers that have a sum greater than 7 are 8, 9, 10, 11, and 12, right? And there's 15 of them. Got it? So we kind of know how to do that. Okay, next one. I want you to draw a 2-dimensional grid of this one right here. Do you guys know what a square spinner is? It's kind of like you have like a post. You have a post, and they put a square around it. On each edge of the each edge of the square has A, B, C, or D on it, or 1, 2, 3, 4. Okay. So I can't draw a picture of it. I could show you a picture, but it's like this right here. I don't know if you guys can see that. There's square spinners. You can make a triangular spinner. Okay, a twister. You guys see those? See what I'm saying? You guys can see those? Can you guys see those from right here?
No. Oh yeah.
That. Square spinner and a triangular spinner. No, you don't have to do it. You guys know what those are? Got them? Like a top. Yeah, it's like a top. You spin it. Okay. You know what? We were going to draw. If you had a square spinner marked A, B, C, D, and a triangular spinner marked 1, 2, 3, then what would your table look like? Your grid. All right. That's enough on that one. I'm going to go into another thing right here. We got to talk about events. Now, you got this paper over here that gives you the definition of events. It says marked AB equals subsets of the sample space. Subsets of the sample space is what it is. We say that an event A occurs if an outcome is in the set A. Okay? So, what is a subset? Let's go back to this problem right over here. What is, when I said rolling a sum of 7, well, let's say that the dice have a sum of 7. I mean, I had this right here was 1 and 6, 2 and 5, 3 and 4, 4 and 3, 5 and 2, and 6 and 1, right? That would be my subset. I would mark that as my subset. That means it's a set within the sample space, right? Does that make sense? Yeah, the 7s. All the pairs of dice that sum up to a 7 would be a subset of the whole sample space. Let's go back to this one. Okay. Let's see, rolling a die and tossing a coin simultaneously. Everything that has a heads in it would be a subset of the whole sample space, right? So the whole top row right here would be event. So I would say, what is the event or the event of rolling a heads with a number? Well, there's 6 different outcomes, right? And so my subset or my event would be the top row right there. Does that make sense? Or I might say of rolling an even number. So how many are in that? That would be heads 2 and tails 2, heads 4 and tails 4, heads 6 and tails 6, right? Okay, so all those would be a subset of the whole sample space. That's an event. You guys understand what I mean by the subset? Okay, so that's what it is. Now, you guys, Venn diagrams. This gives you a brief understanding of Venn diagrams. That big pamphlet I handed you is going to explain Venn diagrams in more detail. But just to give you an idea of the words union, intersection, and complement. Okay, we have 3 words right here that you know. Union that means you're going to take all the events that are in both A and B. Okay? And we use this notation, A with a U in between B. So if you had 2 sets, A and B, it would be A union B would include all of them. Now, look at these Venn diagrams. A Venn diagram basically is a rectangle with circles in it. And the circles represent subsets. The big rectangle represents the sample space, which we call a universe. Do you guys understand that? That's our universe. And A is a subset of it. Look at down at the next one where it says union. If you have 2 subsets, A and B, their union would be the shaded area. Everything included in both A and B. Okay? Now, the next one down is an intersection. An intersection we write like this, A with an upside down U and B. And sometimes they use this symbol right here. They use an upside down V. A intersection B. That means it wants all of the numbers that are in both subsets at the same time. Okay, and notice they shaded in right here the area in between A and B. That's because it's in both circles at the same time, isn't it? And then the last one is what we call a complement. Complements have, depends on what math book you read, have 7 different notations. But that's one. Here's another symbol for complement. Sometimes you'll see that symbol. And basically what it says, a complement is the elements that are not in A. So if I have a subset A, it would want all the elements that are in the universe that are not in A. And so if you'll notice right down here, they shaded everything out of A in that universe down there. Does that make sense? You know, I like to use the word this is, union is or, intersection we use the word and complement we use the word not. Okay? A or B, A and B at the same time, and not A. Does that make sense? Okay, so using this paper right here, you need to know those symbols right there. Now that pamphlet I gave you guys, this is your job. I kind of give you a rough overview of it. The pamphlet explains really clearly about sample spaces, about Venn diagrams. By the way, a Venn diagram, these are all Venn diagrams in that paper right there, those rectangles with the circles in them. They were named after a guy, his last name was Venn, okay, and you'll explain that in here. That's why they call them Venn diagrams, okay. He's famous now, okay, his name was John Venn, all right. Is that what it says in that pamphlet? Okay, and it was just a way to organize subsets in a sample space. Your job, by next time you guys come back to class, is to read through that pamphlet, and there's some assignments in there. You need to answer all the questions that are in there. Okay, that is your assignment. I will grade that. We will grade them, and then I will have you guys keep them to study for the test and to use as a reference for the rest of this domain. Okay, so you have homework to do right now. I'm going to let you guys do that. I would suggest you work together on this while you're in class right now. You might want to read the first page or two together, and then you might want to read the first page together. The first 2.5 pages, all they describe is what I've already described to you, but it helps you. It might help you understand it. The next one, because notice there's a backside to all of these. The next one is some it teaches about set notation, which I taught you about, but it goes in more detail and probably help you understand a little bit better. And then it gives you some Venn diagrams, and then it gives you a chance to do some on your own. Okay? When you get back to the Venn diagrams, and then I give you an assignment. Okay? I want you, anything that asks a question that you're supposed to answer, I want you guys to answer. And then the last couple of pages, last 3 or 4 pages are assignments, last 2 especially, okay? So that's what you have. All right, this is due next time. It should be fairly straightforward, hopefully. We've kind of talked about everything in it, okay? Yeah, I read through it.